This is systems. We're going to talk about what a system is after. But all of these are examples of systems. Notice that there's more than one scale in each situation. So what did we say with the first one? Which one weighed the most? The cylinder had to weigh the most, because if one cylinder is 2 spheres and one sphere is 6 cubes, the cylinder weighed the most. Who weighed the least? Cubes. Because if one sphere is 3 cubes, that would mean that if you had one sphere, it would be 6 cubes. The cubes weigh the least. What did we say for the balancing? What would balance 2 spheres? So one cylinder would balance 2 spheres. One cylinder. So we said that because if 1 cube is 2 cylinders, I can replace this 1 cube with 2 cylinders. And 3 cylinders is 6 cubes. That means 1 cylinder is 2 cubes. Okay? This guy. So we know that all 3 spheres add to 12, meaning each one weighs 4. So if this guy's a 4 and it adds to 8, how much is a cube? Or yeah, cube? 2. Good. So sphere is equal to 4. Cube is equal to 2. All right. So I kind of gave you a hint with this one. We knew that a cube plus a sphere is 13. So I can go over here and say cube plus a sphere would be 13. Meaning there's how much remaining for the 2 spheres? 8 remaining. 21 minus 8, 13 is 8. And so each sphere has to be 4. So these are each 4. A sphere is equal to 4. Meaning if that's the case, what is the cube worth? Has to be 6 to add to 14. So now that I know that the cube is 6, what is a sphere? Sorry, cylinder, thank you. Cylinder 7. Good. All right, this one I think requires a little bit of guess and check. Unless you had another, did you guess and check this one? No? Didn't get it? Did anyone get it? Yeah? 2, 5, 2, 4. And then 5, 4. That would do it. Okay. There is a way to solve this without guess and check, and that is where we would learn about systems of equations, making an equation out of each one of these. So, and solving this. So, for example, if a sphere was x and a cylinder was y, we can say that adds to 7. And so a cylinder, let's call cube z, adds to 6. And we said the cylinder, which is y, plus a cube is 9. And we can actually algebraically figure this out. There is a way to do this. I can show you. Might not mean much to you right now, but we're going to learn how to do that this unit. How to algebraically solve situations like this so we don't have to guess and check. Okay, next page. Really quickly, let's define the whole point of this unit. The reason why you're here. The title. What is a system of equations? So a system of equations is 2 or more equations with 2 or more variables. For example, 2 or more equations with 2 or more variables. 2x plus y equals 7. 3x minus 2y equals 8. This whole thing together is called a system of equations. There's more than one part working together, right? Like when you have the systems of their body, there's multiple parts to it. So a system of equations, there's multiple equations. In this unit, I'm going to be asking you what a solution is. And so if you have 2 lines, two linear equations. What do you think is the most interesting part about two lines? Where they cross. What do we call that? The intersection. The solution is the intersection. The intersection of the two lines. It's the point on both lines. So it's the one point they have in common that's on both lines would be the intersection point. Okay, so to verify the solution means to check the answers. To check the answers and show they satisfy the equations. We like to say they satisfy the equations. Okay, so I'm going to give you an example. If I had a system of 2x plus y equals 8 and 3y equals 12. Solution, well, can you figure out what y is first of all? Y is 4, right? So if y is 4, what's x? 2. So the solution is 2 and 4. X equals 2, y equals 4. Okay? So if I were to check or verify my answers, I need to sub it in to those equations and prove left side equals right side. So let me show you. So if I'm checking with 2x plus y equals 8, I need to actually sub it in. 2 times the x value. What's the x value? 2 plus 4 equals 8. That's 2 times 2 plus 4 equals 8. So we actually treat the left side separately from the right side. 2 times 2 is 4. 4 plus 4 is 8. So does 8 equal 8? Yes. Okay. And then I'd also sub it into the other equation. 3 times the y value equals 12. Yes. Because that's the equation here. Okay? That they gave us. That was the system. And then, so 3 times 4, 12 equals 12. Okay, so we're proving left side equals right side. That's my verification. I sub in my answer to the equations that were given and prove that it actually works, that that's the solution. That point is on both lines. It works for both. It satisfies both. See, if I sub in a point that's only on one of the lines and not on the other, it'll work in one of them, but not the other. Okay, I want to fly through some of this. Okay, let's skip this guy, fishes, and go to some of the word problems really quickly. Okay. So you need to be able to make equations in this unit. I'm going to zoom in a bit. So when I ask you to make an equation, if an equation's not given, you actually have to define your variables. 3 shirts and 2 pairs of jeans cost $230. 2 shirts and 4 pairs of jeans cost $340. How much is a shirt and how much is a pair of jeans? What you're looking for is your variables, right? Because that's your unknown. You don't know how much a shirt is and you don't know how much a pair of jeans is. So we're going to choose a variable for each one of those. What do you want to use as a variable for a shirt? S. So if we're going to use S, we have to define it. Is it the number of shirts or is it the cost of a shirt? It's saying how much is a shirt? The cost of a shirt. You can't just say S is a shirt. Sorry. It's either going to be the cost or the number. One of the two. just say S a shirt, that's not specific enough. Okay, what do you want to use for jeans? You're so creative here, hey? J. So J will be the cost of a pair of jeans. It's funny how it's called a pair. It's just one of them. Anyways, food for that. Oh, there's two shoes. You don't call a pair of shirt. Exactly. That's my point. Okay, so now we want to make a system. So to make a system, what is a system again? Two equations. We want to make two equations. Our unit, we're not going to have more than two equations. It'll be two equations. We want to make two. Okay. Okay, good. So 3 shirts, 2 pairs of jeans cost $2.30. That's one equation. 3 S's plus 2 jeans equals $2.30. That's one equation. Then they say 2 shirts and 4 pairs of jeans cost $3.40. So that would be 2S plus 4J equals $3.40. So there's my system. Okay? So in this part of the lesson, we're not learning how to actually solve it. I want you to be able to make the equation and verify the equation. Okay? Now, if you want, you could guess and check. But I'm going to tell you, unless someone can figure it out, how much each was. Okay? So, in this unit, are we going to learn how to solve this? Yes. Right now, you don't know how to solve it. You don't know how to, you could probably solve it guess and check, but do you know how to solve it graphically? Do you know how to solve it algebraically? Probably not yet. Okay, unless you learned this before somewhere. So let's move on. Next guy. Omar and his brother go to the local candy store to buy some treats. Yum. Omar spends $5 and buys 40 sours and 18 licorice. Muhammad spends $8 and buys 50 sours and 40 licorice. How much does each type of candy cost? Okay, so what variables do you want to use? S and L. S and L. Haha. So what will S stand for? Nope, not just sours. The cost of a sour candy. Okay, and L will be the cost of a licorice. Okay, so now we need to make a system. So we need to make 2 equations. What's one of them? 40S, 40 sours, and 8, so and is plus. 18 licorice was $5, so equals 5. The next one is equals 8. Good. Okay. All right. So the rest is just like an assignment. It's part of the assignment. Okay. And the answers are given. So you're practicing making the equations, all part of the assignment, okay? So I want you to make the equation. So you look, word problems, it's not looking for the solution, it's just looking for your equations, your systems. Okay, that's what I want you to practice doing. All right, so we're actually going to open up our workbooks now. So that's Thursday's lesson done. Yes, that's it. Do you see why it was fine to put them together? So Thursday handout, good. Let's do the lesson 1 now. 613? 17. Oh, so close. Your name's on the board. I need your workbooks today at the end of the lesson to look at. Okay? So I'm just going to, 1 second. I need to stop.